Hey guys, so 11.5, this last section in chapter 11 is working with the distance and midpoint formulas. Okay, so our goal here is to learn how to use these two to find the distance and midpoint of line segments on the coordinate plane. Right, so we're working with the xy plane. So if you're given like 2 points and you draw the line in between them, you could find that distance using the distance formula. And you can also find the midpoint between those 2 points by using the midpoint formula. Okay, so let me explain what these two come from. All right, so the distance formula is actually just the Pythagorean theorem. That's why we learned it right after learning the Pythagorean theorem. So if you're on the coordinate plane and you're given 2 points on that coordinate plane, so let's say like this point and this point, right? In order to find the distance between these two, what we're actually doing with this formula is basically finding the hypotenuse. This formula is basically finding the hypotenuse between this right triangle. Okay? So, we create this right triangle. Basically, all you have to do is count up from here to here. That's going to be the x part. Okay? That's there. And then count up the difference between the y's. That's this part right here. And you square both of them. And that's going to be equal to, that's a squared plus b squared. That's going to be equal to c squared. Okay, so that's why we take the square root of the whole thing, because you have to take the square root of that in order to actually find that distance. So that's where it comes from. You could totally just memorize this formula and use that, plug it in for y1 and x1. Okay, so this is like x1, y1, and this up here is like x2, y2, right? 0.1 and 0.2. So you just plug those in to the formula and solve. Now, in order to find the midpoint between these two, we know it's going to be somewhere in between. Let's just say in purple, it's like right there. Okay, so say it's that point. All you're going to do there is finding the average of the x's, add up the 2 x's and divide by 2, and the average of the y's. Add up the y's and divide by 2. And that's going to get you your midpoint. Okay, so I'll show you what it looks like in some examples. So if you just have to find the distance between 2 points, okay, always write down here, just like we did with slope, right? Write down what's x1, what's y1, what's x2, and what's y2. And you can choose either one of these points to be 0.1 and 0.2 as long as you're consistent. So we're going to plug it into the distance formula, the square root of, parentheses, x2, so 2, minus x1, so minus negative 3 is the same as plus 3 squared, plus y2, 3, minus y1 squared. Okay, so we can solve this. We've got d equals 2 plus 3 is 5. 5 squared is 25. Plus 3 minus 1 is 2. 2 squared is 4. So it's the square root of 25 plus 4, which is the square root of 29. That's the distance between the two. All right, now number 2, we have to work backwards. Okay, so the distance between those 2 points is 5 units. We want to know what a is. Okay, so we're going to use the distance formula. We've got x1 here, y1 there, x2, y2, and the 5 is our d. Okay, so d, 5, equals the square root of x2, 1, minus x1, 4 squared, plus y2, 6, minus y1, a squared. Okay, so we've got one equation. We've only got one variable, that a, and we have to solve for it. So the first thing we got to do is we can simplify on the inside. We can simplify this, but we also want to square both sides because we want to get rid of that square root. All right, so let's square both sides. So those cancel each other out. 5 squared is 25 equals, we know that 1 minus 4 is negative 3, and negative 3 squared is positive 9, plus 6 minus a squared. Okay, we want to keep trying to isolate this, get it by itself, so we need to subtract 9. Subtract 9 from both sides, we get 16 equals 6 minus a squared. One down. Now we can take the square root of both sides, okay, to get rid of our squared. And square root of 16 is 4. So 4 equals 6 minus a. So now you can basically subtract 6 from both sides. So negative 2 equals negative a. divide both sides by -1, and 2 equals a. Okay, so that's how you get that. Now working with midpoint is pretty easy. You just have to find the average of the x's, average of the y's. Once again, keep them straight, what you're working with. x1, y1, x2, y2. Okay, so if we want to find the midpoint is just the average of the x's. So x1, -3, plus x2, 7, divided by 2, and the average of the y's, -1 plus -5, which is the same as -5, divided by 2. So you just simplify both of those. You get -3 plus 7 is +4. 4 divided by 2 is 2. And -1 minus 5 is -6. -6 divided by 2 is -3. So the midpoint is 2, -3. Just like we did with the distance formula, you can work backwards with the midpoint formula as well. Okay, so I'm going to give you the actual midpoint, and I give you one of the endpoints. You want to find the other endpoint. Well, this one is actually pretty easy, okay? If you try to work backwards with the formula, it gets tough. Okay, so you probably want to think of it this way. You're going to have endpoint, then midpoint, then endpoint, right? So that one endpoint that they give us is -2, -4. They give us the midpoint, 3, -3. And we need to find the other endpoint. Right? Well, if you just think about this, what the midpoint means, it means it's you're halfway there to the other endpoint for both the x's and the y's. So if you count the steps from the x to that midpoint, then you just add that again to get to that endpoint. Okay, so from -2 to +3, you're moving 5 spaces in the positive direction, right? -1, 0, 1, 2, and 3. 5 spaces in the positive direction. So you're just going to move another 5 spaces in the positive direction, and 3 plus 5 is 8. Okay? Now for the y's, what are you moving? Well, from -4 to -3, you're adding 1. What are you doing if you get from -4 to -3? See, from here to here, you add 5, so you need to add another 5. Right? From -4 to -3, you add 1, so it means we need to add another 1. -3 plus 1 is -2. So our final answer here is 8, -2. Okay, and lastly, I'll help you set this one up. There's actually 2 ways to do this type of problem. Okay, you have the coordinates of a triangle, so we need to draw this so we can see what it looks like. -5, -2, that's 1 point. 0, -4 is another point. And -2, +3 is our third point. So this is a triangle. We want to know, is it a right triangle? Okay, so there's a couple things we could do here. One thing you could do is, right, method 1, is you could use slopes. Okay, so ask yourself, where do you think the right angle is? Well, it looks like the right angle might be here. But you can't just assume that's a right angle. You have to actually show me that. Well, back in like chapter 6 or 5 or something like that, we did work with slopes in parallel and perpendicular lines. All right, so what we could do is we could show that this segment right here and this segment right here are perpendicular. How do we do that? Remember, perpendicular lines have opposite reciprocal slopes. Okay, so what you could do is you could find the slope of this and the slope of this, show me their opposite reciprocals. If they are opposite reciprocals, then you know that's a right angle. If they're not, then you don't have a right angle, so it's not a right triangle. Okay, so that's method 1. Method 2 is distance. Okay, so you can use the distance formula to show me the Pythagorean theorem is true. Okay, so what you have to do for something like this is you have to find the distance of this, make that A, the distance of this, make that B, the distance of this, make that C. If you could show me from the distance formula that a squared plus b squared equals c squared, then it's a right triangle. If it doesn't work out, then it's not a right triangle. So choose one of those methods, try it on your own, and we'll see where you get in class.